Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll discuss question number 44 of NEET Physics paper 2015. This is number 44, across metallic conductor of non-uniform cross-section. So it's a metal conductor, this is uniform cross-section. This is uniform cross-section. The area of cross-section is same at any place. Non-uniform means it might be increasing or decreasing. Suppose I take this way. This is non-uniform area of cross-section. Now, in this non-uniform cross-section, a constant potential difference is applied. Now, what is applied? A constant potential difference is applied to this conductor. Suppose that potential difference is, suppose V volt is applied. So the terminal potential difference here is V volt. V is the potential difference between the two ends. The quantity which remains constant along the conductor is. So we have the options: the drift velocity, the option 1, the electric field, the option number 2, the current density, say J is a vector quantity, this is also a vector quantity, these are all vector quantities, and the current is a scalar quantity I. So out of these, when current starts flowing from here and moves through this conductor, which of these quantity will remain constant in case of non-uniform conductor? So it is as I suppose I take this case that area is changing, suppose increasing from here to here. So area is increasing. The current density is basically which remains constant. The current density will not remain constant because current density is the current flowing per unit area. Because area is changing, therefore the J is not constant because I is always the same. Because we can think of this, how can you say that? Because A is suppose in this case increasing, in other case might be decreasing, but this will change. So this is changing. This is in this case it is decreasing because A is more, so J is less. In this case, in this situation, I is increasing and J is decreasing, so it is not constant. Why I is constant? And similarly, the drift velocity, electric field is the potential difference applied across the ends divided by L. If I take any cross section, suppose I take this cross section, this one. So from here to here, the cross section is gradually increasing. Increasing from A to A plus D. So there is a slight increase in the area of cross section. And the potential difference, because the potential difference is different for different cross section, because the resistance is changing, so the potential drop will change. So this cross section or for any other cross section, the potential difference for the same length, if I take the same length here, then the potential difference will be different because the resistance will be different. The resistance here and there will be different. Resistance is given by rho L over A. Rho is constant, L I take constant, but then area of cross section is different. Here is more, the resistance will drop, the potential drop will be there, so that will also be different. So this is different. If in this case I say, then the resistance is decreasing, so potential drop will also decrease, so this will also decrease in this situation. So this is also changing. Drift velocity, Vd is I upon NEA. This also depends upon area of cross section. This will also change. The only quantity is I, but why I is constant? This is constant. This is correct. Current will remain constant. But why it is constant? Because you can think of this non-uniform cross section as a combination of few resistances in series, lot of resistances say in series. This one to this one, this is one resistance. We can imagine that this is one resistance, this is another resistance from here to here, this resistance different, from here to here there is another resistance, from here to here there is another resistance. So you can cut this into very similar small pieces. Then these resistance are connected in series, and this will the last resistance that is connected across the battery of V volt. So each section, however small it might be, the resistances are R1, R2, R3 and R infinite. So they are in series, and in series, even though the resistance are different, but the same current will flow throughout. When number of resistances are connected in series, the same current will flow. Whatever current has to flow, the same current will flow through this. So the I will remain constant irrespective of not uniformity in the area of cross section. So therefore current will remain same, and that is the answer to this question. Okay, thank you.